Section 5.1, designing samples. A lot of what we're going to talk about in this chapter, we talked about in the preliminary chapter at a very elementary level. We're going to obviously get a little bit more deeper into some of the topics, but you're going to see some of the same vocabulary that we've already been using throughout the year up to this point. Observational study. Observational study remembers when we observe individuals and measure variables of interest, but do not attempt to influence the responses. An experiment, we deliberately impose some treatment on, that is, we do something to individuals in order to observe their responses. Remember, the word treatment is what we want to use, and that's how we are going to determine whether something is an experiment or an observational study. If there is a treatment imposed, then we know it's an experiment. If there isn't, then it's usually an observational study. Population and sample. The entire group of individuals that we want information about is called the population. The sample is the part of the population that we actually examine in order to gather information. Okay, right now, with it being a presidential election year, if you look at the newspaper, you look at some things on the internet, you watch the news, anything like that, you see a ton of polling done now where it'll tell you what the sample size is, and then the intended population then would be the actual voters on election day. So that's an idea of a sample versus the entire population. Sampling versus a census. Sampling involves studying a part in order to gain information about the whole, where a census attempts to contact every individual in the entire population. Obviously, sampling is much easier to do. It is much less costly to do than a census where we would just simply talk to everybody, which is why in the United States we do a census once every 10 years because it is very costly, number one, and number two, it's very difficult to do because it's very difficult to attempt to contact every single individual that lives in the United States. Different types of sampling methods. A voluntary response sample consists of people who choose themselves by responding to a general appeal. Voluntary response samples are biased because people with strong opinions, especially negative opinions, are most likely to respond. Examples of voluntary response samples would be online polls, mail-in polls, telephone polls, things like that, because people are choosing whether they are going to respond or not. You'll see if you watch some of the local news, they'll have a call-in telephone poll to respond to a certain question, very biased because it is a voluntary response sample. Convenience sampling. Choosing individuals who are easiest to reach is called convenience sampling. Convenience sampling, again, would most of the time represent in a biased sample because you're not using statistical methods in creating your sample. Sampling method is biased if it systematically favors certain outcomes. Remember that definition. Sampling method is biased if it systematically favors certain outcomes. Looking at our first example here, 5.2. For each of the following sampling situations, identify the population as exactly as possible. That is, say what kind of individuals the population consists of, and say exactly which individuals fall in the population. If the information given is not complete, complete the description of the population in a reasonable way. Letter A. Each week, the Gallup poll questions a sample of about 1,500 adult U.S. residents to determine national opinion on a wide variety of issues. So let's start with here the population. The targeted population here, our sample is 1,500 adult U.S. residents. So our population is going to be all adult U.S. residents. So if you know the sample, then you are going to know exactly what your targeted population is. We also are to say which individuals fall in this population. An individual within that population would be one adult U.S. resident. Letter B. 2000 census tried to gather basic information from every household in the United States. A long form requesting much additional information was sent to a sample of about 17% of the households. So again, our sample is 17% of the households in the United States. So our population would be all households in the United States. An individual member of that population would be one U.S. household. Letter C, a machinery manufacturer purchases voltage regulators from a supplier. There are reports that variation in the output voltage of the regulators is affecting the performance of the finished products. To assess the quality of the supplier's production, the manufacturer sends a sample of 5 regulators from the last shipment to a laboratory for study. So there's our sample. 5 regulators from the last shipment. So our population is going to be all regulators or all voltage regulators in the last shipment. An individual member of that population would be one of the voltage regulators. Okay, so the idea of this problem is to get you to focus in on what your sample is and what your intended population is. And you have to always make sure that you are creating a sample that is a subset of whatever your intended population is that you want to draw conclusions about. In 1940, a psychologist conducted an experiment to study the effect of propaganda on attitude toward a foreign government. He administered a test of attitude toward the German government to a group of American students. After the students read German propaganda for several months, he tested them again to see if their attitudes had changed. Unfortunately, Germany attacked and conquered France while the experiment was in progress. Explain clearly why confounding makes it impossible to determine the effect of reading the propaganda. So our intended experiment was our variable x, which was reading propaganda. We wanted to know how would reading the propaganda affect the U.S. students' attitude toward the German government. The problem is during the experiment, we have this lurking variable, which we can call z, which was that Germany attacked and conquered France. So why is this confounding? Well, this is confounding because the variables x and y could each be affecting the U.S. students' attitudes toward the German government. So we don't know for sure whether it was the fact that they read the propaganda, or was it the fact that Germany attacked in concert France that is affecting their attitude toward the German government. So those two variables are confounded. Number 6. The National Halothane Study was a major investigation of the safety of anesthetics used in surgery. Records of over 850,000 operations performed in 34 major hospitals showed the following death rates for 4 common anesthetics. There seems to be a clear association between the anesthetic used and the death rate of patients. It appears that anesthetic C is more dangerous. We can see just about twice the death rate of the other 3 methods of anesthetic that was given to the patient. Explain why we can call the National Halothane Study an observational study rather than an experiment, even though it compared the results of using different anesthetics in actual surgery. Okay, so really when we look at this, if we just looked at this and we saw, well, there's 4 different anesthetics, that would be the treatment, the type of anesthetic that the patient received. But why is this an observational study? Well, because we looked at hospital records that had already been done. Hospital records were used after the anesthetics were administered. There was no treatment imposed on the patient. So in other words, the doctors chose what anesthetic they believed would be the best to use for whatever the surgery was that was going on. And then after the fact, we went back and looked at all the hospital records, saw that there were 4 different types of anesthetics used, and we looked and we noticed these 4 death rates depending on which one the doctor chose to use. It wasn't a treatment that was forced upon them. When the study looked at other variables that are confounded with a doctor's choice of anesthetic, it found that anesthetic C was not causing extra deaths. Suggests several variables that are mixed up with what anesthetic a patient receives. Well, depending on the type of surgery that they are receiving, could affect whether they live or die during surgery, which could be confounded then with the type of anesthetic used. Health of the patient at the time of surgery could be confounded. So the health of the patient when the anesthetic was used. Training of the medical personnel using it. So we can see right away that there are several lurking variables that also could be contributing to the death rate of these patients. There's 3 of them. There are probably more that you could list as well. Problem 8. You are on the staff of a member of Congress who is considering a bill that would provide government-sponsored insurance for nursing home care. You report that 1,128 letters have been received on the issue, of which 871 oppose the legislation. I'm surprised that most of my constituents oppose the bill. I thought it would be quite popular, says the Congresswoman. Are you convinced that a majority of voters oppose this bill? How would you explain the statistical issue to the Congresswoman? Well, first of all, this should not be convincing evidence that a majority of voters oppose the bill because this is a voluntary response sample. So the responses are not necessarily representative of all the constituents. Spell correctly here. Okay, so good methods of sampling. Simple random samples. This is basically going to be the benchmark of everything that we are going to talk about throughout the rest of this year in the class. On the AP exam, if you are asked to pick a sample, you are going to pick a simple random sample. This is the benchmark for everything in this class that our samples will be built upon. A simple random sample, abbreviated SRS, and yes, you can use that abbreviation. It is pretty much universal in the statistics world, of size n consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be the sample actually selected. Are these two samples simple random samples to choose 5 students from this class? All the students' names in this class are written on a piece of paper, placed in a hat, then 5 names are drawn from the hat. Would this be an example of a simple random sample? Yes, it would. Every single possible group of 5 students have an equally likely chance of being selected. Second situation, students are placed in rows of 5 to make up 5 rows. So let's suppose that we have exactly 30 students in here. We have 6 rows of 5 students, and now actually the way this is written, let's say we have 25 students. The numbers 1 through 5 are placed in a hat. So we have 5 rows of 5 students. We number the rows 1 through 5. We put those numbers into a hat. We mix it up. And whatever row is drawn, those 5 students are going to be selected for the sample. Is that a simple random sample? No. Okay, and that can be confusing at times, students. The reason this is not a simple random sample is not every group of 5 students is possible. Meaning that it would be impossible for me to have a sample of one person from row 1 person from row 2, one person from row 3, 4, and 5, and so on. Therefore, it's not a simple random sample because every single individual set of 5 students is not a possibility. Random digits. Table of random digits is a long string of digits 0 through 9 with these two properties. Each entry in a table is equally likely to be any of the 10 digits 0 through 9. So when I look at a single entry, it's random as far as what number 0 through 9 we see. The entries are independent of each other. That is, knowledge of one part of the table gives no information about the other part. If you look at table B in the back of your book or any random number table, each entry is equally likely to be any of the 10 possibilities 0 through 9. Each pair of entries is likely to be any of the 100 possibilities of 00 through 99. Each triple of entries is equally likely to be any of the 1,000 possibilities 000 through 999 and so on as we look at groups of numbers. Choosing a simple random sample. 4 steps. You're going to label, which means you're going to assign a numerical label to every individual in the population. You're going to then go to a table. You're going to use table B if you use your book. You're going to have a stopping rule. In other words, you need to write when do you know that you are done obtaining your sample from the random number table. And then you're going to finally identify the sample. You're going to use the labels to identify the actual subjects selected to be in the sample. Other sampling methods. So there are other methods that you will have to know, But in general, if you are asked to come up with a sample, the method you are going to use is a simple random sample. A probability sample is a sample chosen by chance. We must know what samples are possible and what chance or probability each possible sample has. A stratified random sample. To select a stratified random sample, you first divide the population into groups of individuals called strata that are similar in some way that is important to the response. Then you choose a separate simple random sample within each stratum and combine these simple random samples to form the full sample. For instance, if we wanted to sample and I knew that there was a difference between males and females on how they were going to respond, and I wanted to make sure because of that that I don't have a bunch more males in my sample than I do females, we could stratify on gender. So we would separate all the males from females, and now within the males, take a simple random sample of, let's say, 100, and the females take a simple random sample of 100, and mix them now, or combine those two at the end to get an entire sample of 200 individuals, guaranteeing us that we're going to have half males and half females in our sample. Cluster sampling divides the population into groups or clusters. Some of these clusters are randomly selected, then all individuals in the chosen clusters are selected to be in the sample. Example of cluster sampling could be looking at, if we're talking about getting a survey of residents in Rockton, we could take all of the major subdivisions in Rockton, each one of those being a cluster, and now randomly pick one of those subdivisions and interview then all of the individuals within that subdivision. That would be an example of cluster sampling. Problem 10. Campus newspaper plans a major article on spring break destinations. The authors intend to call a few randomly chosen resorts at each destination to ask about their attitudes towards groups of students as guests. Here are the resorts listed for one city. The first step is to label the members of the population as shown. So we take all of these destinations and we label them 1 through 28. Notice we go 0, 1, 0, 2, 0, 3 because we're going to be looking at two-digit numbers. So the first digit, if we're really numbering this 1, is 0, 1, 0, 2, and so on, all the way up through 28. Use table B. So go to your book, look at table B, look at line 131, and choose 3 resorts. So we're looking at the numbers in pairs. Our first one that we are going to select is 0, 5. Anytime we get something that isn't 0, 1 through 28, you go to the next group of 2 numbers. So make sure you're looking at each one in groups of 2. If it's something larger than 28, you just move on to the next group of 2 and so on. The first 3 that you should get are 0, 5, 19, and 0, 4. So now from here, the actual resorts that are going to be included in our study are Beach Castle, number 19, which is Sea Castle, and number 4, which is Banyan Tree. So those are the 3 resorts that we just randomly selected from those 28. Accountants often use stratified samples during audits to verify a company's records of such things as accounts receivable. The stratification is based on the dollar amount of the item and often includes 100% sampling of the largest items. One company reported 5,000 accounts receivable. Of these, 100 are in amounts over 50,000, 500 are in amounts between 1,000 and 50,000, and the remaining 4,400 are in amounts under 1,000. Using these groups as strata, you decide to verify all of the largest accounts and to sample 5% of the mid-size, 1% of the small accounts. How would you label the 2 strata from which you will sample? Use table B starting at line 115 to select only the first 5 accounts from each of the strata. Okay, so we already know we're picking all of the largest ones, so we don't need to worry about that. So we need to worry about what are we going to do with the mid-size ones? And what are we going to do with the small accounts? Well, for the mid-size accounts, it says that there are 500 of them, so we would need to label each account from 001 to 500. Once we labeled each of those, let's go ahead and go to Table B. Start at line 115 and select the first 5 accounts. So now we have to look at the numbers in groups of 3. Anything larger than 500, we just don't worry about it, and we move on to the next group of 3 numbers. So as we move through that group, you pick account 417, 494, 322, 247, and 097. In the small accounts, there are 1,000 of them. So now let's be, or I'm sorry, not 1,000, there's 4,400 of them. So we need to label each of those accounts from 0001 to 4,400. So now for this one, we need to look at groups of 4 numbers. We would pick 3698, 1452, 2605, 2480, and 3716. Okay, you also have a random number generator on your calculator. Let me show you where that's at. If you go to your calculator, go Math, over to Probability. You see Random Integer Generator is right here. So for the mid-size accounts, if you didn't want to use a random number table, you could also generate this from the calculator, which is actually quite a bit quicker. We'd want to generate random integers from 1 to 500. And now when we hit enter, it's going to automatically randomly pick something between 1 and 500. So we would select account 472, hit enter again, account 455, enter again, account 74, enter again, account 258, and enter again, account 203. And that could have been how we could generate our sample too. The nice thing about using a random number generator like this is you can set the parameters and you don't have to worry about, well, what if I got something larger than 500? Now I need to go to the next 3 numbers and to the next 3 numbers and so on. This only is going to give you values based on how you program the upper and lower bounds of what it is generating. Problem 14. Laying fiber optic cable is expensive. And so cable companies want to make sure that if they extend their lines out to less dense suburban and rural areas, there will be sufficient demand and the work will be cost effective. They decide to conduct a survey to determine the proportion of households in a rural subdivision that would buy the service. They select a sample of 5 blocks in the subdivision and survey each family that lives on one of those blocks. What is the name for this kind of sampling? Well, we've separated the subdivision by blocks. We've randomly picked 5 blocks, and then we've interviewed everybody that lives on that block. That's an example of cluster sampling. Clusters being the block on which the person lives. Once we select that block, everybody on the block gets interviewed. Suppose there are 65 blocks in the subdivision. Use the random digit table beginning at line 142 or something else to select the 5 blocks. So if there are 65, we would need to label each block from 1 to 65. And now let's actually go to the calculator and do this rather than the random number table this time. So we go Math, Probability, Random Integer from 1 up to 65, and we're selecting 5 blocks. So we're going to pick block 48, 3, 23. Let's write these down as we go here. 48, 3, 23, 65, and 14. So there's the 5 blocks. Once we selected those 5 blocks, everybody that lives on those blocks would be interviewed for our survey. Cautions about sample surveys. Undercoverage occurs when some group in the population are left out of the process of choosing the sample. Non-response occurs when an individual chosen for the sample can't be contacted or does not cooperate. Okay, so we have 2 things that is tough to control when you are getting a sample. Example of undercoverage would be if we're calling people on a telephone. All of the people who don't have telephones would be left out of the survey. That group would have some undercoverage. Non-response would be call the people and they hang up on me because they don't like telemarketers or they don't want to participate in a survey. That would be an example of non-response. The behavior of the respondent or the interviewer can cause what is called response bias. If I seem to be suggesting an answer to a certain question in the way that I ask it, that is an example of response bias. The wording of questions is the most important influence on the answers given to a sample survey. Again, going back to this being a presidential election, when all of the polls that are being done are conducted, a lot of times they are conducted, number one, where it is automated over the phone, where it's a computer that is actually asking the questions. The reason for that is they want to reduce response bias. The wording of the questions will change. So in other words, if you get called, it may say, who do you support for president? President Obama or Governor Romney? The next person it says, who do you support for president? Governor Romney or President Obama, where they're switching the order because the order in which the names are given can influence the responses as well. You should insist on knowing the exact questions asked, the rate of non-response, and the date and method of the survey before you trust a poll response. The nice thing nowadays about having the internet is you can always find where the data is coming from, how the questions were answered, how did they get their sample, what's the makeup of the sample, things like that, because all the data is listed on the internet. Before, if you were just looking at a newspaper, you couldn't click on something and get all that information, so you wouldn't always know the answer to these questions. If I just look quickly here at a couple of surveys here. Okay, these are the current major samples that have been done to come up with polls. Some things that we'll be talking about here are sample sizes and margin of error are the key things to be looking at when you look at a poll. Notice that all of these polls do not match up. Okay, NBC News poll has it as a tie. Rasmussen poll has Romney up 2 points at this time. Gallup poll has Romney up 7 points. The IBD poll has Obama up 6 points. So there's a lot of difference here. Okay, and that is the variability that happens when we have a sample. If we click on one of these individually, okay, here's the NBC Wall Street Journal poll. Okay, so if we look at this poll going down to the bottom here, it tells you that they both are receiving 47% among likely voters. Then it tells you that they surveyed 1,000 registered voters, of whom they deemed 816 of them to be likely voters. And they tell you that the margin of error is plus or minus 3.1 percentage points for the sample of registered voters and 3.43 percentage points for the sample of likely voters. The smaller the sample is, the higher the margin of error, which is why you have a margin of error greater for likely voters than registered voters. If we look at a couple other ones here. These ones you can actually get even more information. Okay, as I go down here, okay, here's what I was looking for here. It says Rasmussen Reports has been a pioneer in the use of automated telephone polling techniques, but many other firms still utilize their own operator-assisted technology. And we can see the methodology, which we're going to look at here in a second. Okay, this next paragraph, though, down here, daily tracking results are collected via telephone surveys of 500 likely voters per night and reported on a 3-day rolling average basis. To reach those who have abandoned traditional landline phones, Rasmussen Reports uses an online survey tool to interview randomly selected participants from a demographically diverse panel. Margin of sampling error for the full sample of 1,500 likely voters is plus or minus 3 percentage points with a 95% level of confidence, which we will get to later on. If we look at the methodology here, okay, this is where if we went through and we read this, it would tell how they are getting their sample, what factors they're looking at, such as age, race, gender, political party affiliation, all of that kind of stuff, and we can get all that information that we want on how they are producing their samples. If we look at one more here, okay, the last one here, looking at the Gallup poll. For a complete explanation of Gallup's likely voter procedures, okay, so we can see the number of voters, 2,700 likely voters, margin of error plus or minus 2 points. If we click there, we can see the actual questions that Gallup uses to determine whether somebody is a likely voter. How much thought have you given to the upcoming election for president? Quite a lot, some a little. Do you happen to know where people who live in your neighborhood go to vote? Have you ever voted either in person or by mail in your precinct or election district? All these questions are how they're determining who are going to be likely voters then in the election. Some of them you can even click on and you can see the actual questions that are being asked. As far as them telling you, we rotate this, we ask it this way one time, this way another time, again, to try to limit the effect of response bias. Common form of non-response in telephone surveys is ring no answer. That is, the call is made to an active number, but no one answers. The Italian National Statistical Institute looked at non-response to a government survey of households in Italy during the periods of January 1st to Easter and July 1st to August 31st. All calls were made between 7 and 10 p.m., but 21.4% gave ring no answer in one period versus 41.5% ring no answer in the other period. Which period do you think had a higher rate of no answers and why? Explain why a high rate of non-response makes sample results less reliable. Well, it would make sense here that the July 1 to August 31 has a higher no answer rate. Why would that be? Because weather is nicer. So people may be outside. People vacation more during this time, so they wouldn't be at home. And so on. Why would a high rate of non-response make sample results less reliable? Well, the reason being is the people who do not answer are left out of the survey. Newspaper article about an opinion poll says that 43% of Americans approve the president's overall job performance. Toward the end of the article, you read, this poll is based on telephone interviews with 1,210 adults from around the United States, excluding Alaska and Hawaii. What variable did the poll measure? What population do you think the newspaper wants information about? What was the sample? And are there any sources of bias in the sampling method used? First, our variable. What variable are we attempting to measure? The job approval rating of the president. What's our population? Probably all U.S. adults. What was the sample? 1,210 U.S. adults. And what's our source of bias? People from Alaska and Hawaii are not sampled. Another source of bias could be the ring no answer we just talked about, or people without telephones are not included. So anytime that you are selecting a sample to draw conclusions about a population, there are always sources of bias that are going to be in every single sample. The goal is to limit as much of the bias as you can by using good sampling techniques. Wording bias. Comment on each of the following as a potential sample survey question. Is the question clear or is it slanted towards a desired response? Some cell phone users have developed brain cancer. Should all cell phones come with a warning label explaining the danger of using cell phones? First of all, is this clearly stated? Yes. Is it slanted? Probably slanted in favor of warning labels. Do you agree that a national system of health insurance should be favored because it would provide health insurance for everyone and reduce administrative costs? Is this clear? Yeah, pretty clear. But this is slanted. Toward favoring national health insurance. In view of escalating environmental degradation and incipient resource depletion, would you favor economic incentives for recycling of resource-intensive consumer goods? Is this a clear question? No. It's not clear. There's a lot of words in there that many people probably would not even understand what the definition are. So that means that it is way too technical. And it seems to be slanted in favor of recycling. Last two slides here again are the summary of this section. Boldface words, make sure that you understand definitions and how to explain what each of those things mean. If there's things in here you do not understand, make sure that you are getting in the morning and getting some extra help on anything you may need help with.